Hi everyone, welcome to this tutorial. Today we are going to learn about stacks, which is a continuous for the data structure. I'm going to hide the video for now because I need space in here, so we can start. First of all, I wanted to mention that you may be feeling very confident in programming, this is good, but some of you may have no idea what you're doing, and this is very normal. So, if you have any question, please let us know and we are here to help you. Okay, back to the topic. What is a stack? Stack is a collection of objects that supports fast last in and first out. This is very important to remember. So LIFO, last in, first out. But what does this actually mean? This means that the last element that you push is the first element that you can pop, so you can retrieve. Unlike lists or arrays, stacks typically don't allow for random access to the object that contain. You have learned in arrays that when you retrieve an element, you use the index. For example, right here, it could be 0, 1, 2, index 2. But in stacks, this is not the case because you cannot retrieve the element right here, but you can only retrieve the last element that you have inserted in the list. The insert and delete operations are also often called push and pop. So let's see a real-world analogy. I think you may have all encountered this situation where you have a stack of plates. If you want to retrieve these plates right here, it can be very difficult because all the plates may just fall and break. So if you want to retrieve here, you have to start from top to bottom. So you retrieve the first, the second, and so on. But the first plate here is the last plate that has been placed in the stack. We can see a more relatable example with the internet web browsers, which store the addresses of recently visited sites in a stack. Each time a user visits a new site, that site's address is pushed onto the stack of addresses. So, to see what I actually mean, let's visit the site Code for Albania. We are here at the home page, and let's suppose we want to go to the challenge section. Then, okay, we navigate and we want to go to the contact. But, okay, this is not what I wanted to find. Let's go back to the challenge. And to do that, we do the back button. And so, if you notice, when you press back, you don't go straight to the home page, right? So you go to the contact, you go back to the challenge. How can we actually express this in code? We can use arrays. So this is more to show that we can use a stack of URLs. The first one would be the home page, the second would be the challenge, and then the contact. Let's express this in code in order to understand it more. So right now we are at the contact. Let's go back to the home page. Yes, just a minute. Okay, first step, we declare the array. Next, we append the homepage URL. We said we wanted to visit the challenge section, so we go to the challenge. Okay, good. Then we go to contact. Okay, now we are appending, so we are pushing elements to the stack. So we are pushing the plates. So we are homepage, challenge, and contact. Okay, nothing happens for now because we haven't printed anything, but if you want to print the page where we are at, the contact one, we use website.pop. Now the websites list contains codeforalbania.com and codeforalbania.com/challenge. We now want to retrieve the challenge URL. Okay, let's print the array again. Now we only have code for Albania. And now we also want to retrieve the home page as well. So each time that we press back in here, we are executing pop function. So challenge and code for Albania. But what happens if we keep using pop? We can see that we get an error, index error, pop from empty list. So make sure when you use this in programming to first check if the list is empty or not before popping, otherwise you will get this ugly error right here. I hope that was clear. I'm going to go back to the slides now. And this is another simple example. So we declare an array, we append eat, sleep, code. Code is the last element that is appended, so it will be the first that will be out. As you can see right here, code, sleep, then eat. And then we have again an index error because we are popping from an empty list. Okay, so this is an exercise which I'd like to think also as a game, because you have plenty of options here. We have 3 stacks, S1, S2 and S3. You can notice that in stack 1 you have a set of unordered numbers. What we want to do is sort the numbers using append and pop methods in the following 3 stacks. So we can use S2 and S3 as temporal container to temporarily store the numbers and access them when we need them. And we can use one of the containers, in this case I'm choosing S2, as a final one to store the ordered numbers. I would suggest before programming, if you are not clear about something or you are not sure how to proceed, you just make a schema and express it in code. So, as we can see here, 4 is the last element that is pushed, so it will be the first element that will be popped. I'm going to use it S3 as a temporal container, so I'm going to push 4 in S3, and we can see right now that 2 is the next accessible item. We push 2 in S2, we push 3 in S3, so I push 3 in S3 because we have 4 here and we have 2, and it is more convenient for us to put the smaller item as in the top stack, as the last element. But we can see now that 2 is accessible. Also 1 is accessible. So what would happen in this case? We can send 2 to S3 and we can access 1 to put it in S2 and use it as a final container, because 1 is actually the first number that we actually need to keep sorting the numbers. So we are pushing 2 to S3 and continue with 1. Good, now we can have a final visualization of what is actually happening. We have 1 in S2. We want to push 2, 3, 4 in S3. And oh look, what we have here, we have 5, 6, 7. This was actually done on purpose. We put them in order because we don't want the video to last an hour. So we insert 5, 6, 7 to S2, and now we have the final result in stack 2. But to express this in code, we can use, we can go back to the first step. I'm just gonna copy this. Just a minute. Okay, nothing happens now. I'm just running to avoid any possible errors. So what was the first step? This is what I meant when creating a schema, because, okay, I did all these operations, but for sure I don't remember which was the first one. Okay, this time I remember because we don't have many options, but what we want to do is push 4 into S3. So stack 3, append. Okay, we want to retrieve the object from stack 1. We are going to declare this number 4. Number 4. Nothing happens because I haven't printed anything. I'm gonna print all stacks. Stack 2. Oh, sorry. In order. Stack 2 and stack 3. Okay, so this is okay, but I want to write as less lines as possible, because in programming it's better to keep things organized and write less lines, because the other programmers have to understand what you have done, and actually you have to understand what you have actually written in your logic, because you won't remember what you write in a month. So I'm just gonna express this using this. So not declaring the variable, because we can straight do it in one line, and put a comment. So what we did is push 4 into stack 3. Okay, I'm not gonna comment every line, but you get the point. So comments, organizations, less lines. The next step is pushing 2 into S2. Dot append stack stack 1 up. Good. Now the next line was number 3 into stack 3. Okay, so let's go on. Yes, now from S2 we want to push number 2 to S3. Stack 3 dot append stack 2 dot pop. Okay, we're on the right track. Then the next step was number 1 to stack 2. So yes, now we are using stack 2 as a final container. So it was in stack 1. Okay. And then what we want to achieve is retrieve 2, 3, 4. So we have a repetitive combination here from S3 to S2. Stack 2 dot append stack 3 dot pop. So we are going to repeat this 3 times. And another step is retrieving 5, 6, 7 to S2. This is also repetitive, so stack 2 dot append. We are in stack 1 right now, dot pop. Okay, 1, 2, 3, 4, 5, 6, 7. This is the final result that we wanted, but there are 2 things I don't like in here. One is too many lines, I don't like it. Then we have many repetitions, like it's this one and this one. And I also don't like something else. For example, let's suppose I want to insert into stack 2, for example, append stack 1 dot pop. So yes, we will get an error. It's very common to check to have error handling in programming to avoid this kind of errors, because if you work in a company in the future, it will have bigger consequences than just this line. So keep in mind error handling, less repetitions, and make it more organized. Some comments, but not too much. And okay, I want to organize this right now. So what I'm seeing here, that we are popping from stack 1. And there is a chance for stack 1 to be empty and retrieve this error. So I'm gonna use an if. The length of stack 1 is different from 0. Okay, good. Okay, I am actually noticing that I'm popping from stack 2 as well. I don't like this either, so or length stack 2 different from 0. Okay. So far, so good. I can just leave it like this, but I think I can do it better. I'm noticing here some repetitions. I can use, you have learned, while stack 3. Okay, wanted to do the same. Stack 3 is different from 0. I'm going to remove these 2 lines and do this. I'm noticing the same scenario here as well. Okay. While let's remember, stack 1 is different from 0. Okay. Okay, I can retrieve the same result. And as I said, it's better to keep things organized. This can be done much better, but we can use functions, create classes. We'll learn about classes in the future. But for now, we can just leave it like this. But hey, I forgot something. I want to use Reci. Because if we want to do this no, let's suppose just a minute, my internet is not so good now. Stack 2, okay, what is empty here right now? Stack 3, append stack 1 dot pop, stack 1, stack 1, stack 2 dot pop. Okay. And we repeat this. Yeah, error handling. And you can actually see also the line which is causing the error. So anyway, this was more to also do a review of what you have learned so far, like using if conditions, whiles, and length. This can be actually done better for sure. So I will share this code and you can keep playing with it. Going back to the slides. I also want to mention that there are many ways you can do an exercise. This was one of them, but if you had another exercise, another solution in mind, just try it and you can share it with us. I had to interrupt the video because we don't have much time. I was planning to do another exercise, but we are going to have an exercise session about this topic anyway. I hope you enjoyed the video, the topic in general, and as always, if you have any question or feedback, let us know. So keep coding and we'll see each other soon.